Hey everyone, here's a intro video to our new unit, which is linear functions. We're going to start with the idea of slope or rate of change. So rate of change meaning the way our two variables change over one period versus slope, which is the overall change. So what is a rate of change? A rate that describes how one quantity changes in relation to another quantity. So pretty much what I just said, it's one variable, usually our dependent variable, how it changes in relation to the independent variable. So we calculate slope as the change in y over change in x. You should remember this from the Unit 3 tables that we did, where we had to find out our y equals mx plus b equations by using our delta y over our delta x. A way to find that is y1 minus y2 over x1 minus x2. A lot of times in class you'll see me finding slope as y2 minus y1 over x2 minus x1. I prefer to use this formula. It is the same formula, just ordered differently. It means the exact same thing. The answers will come out exactly the same. It's just about how I order the problem. So as long as you keep the 1's on top of each other and the 2's on top of each other, you'll be fine. So notice y2 minus y1 is on top of x2 minus x1. And this is our slope formula. So this is your first formula for Unit 5. It should be something you saw last year and are somewhat familiar with. So let's try and use that slope formula. I'm going to prove to you here that it doesn't matter what we call x1, y1, and what order we do. So let's see, this is time in hours, and this is cost in dollars. So time we know from before is always our x, and cost will be our y's. So let's just label our points as we go along. Call this x1, x2, x3. Just by the order we see it. The first x we see, second x, the third x. And so then the first y, the second y, and the third y. What these really are, they're set of coordinates. So we have coordinate 2, 7, which is x1, y1. We have 4, 14, x2, y2, and 6, 21, x3, y3. So we have three different points that we can use, and we can find the slope using any of them. So I'll take the one that I've been using, m equals y2 minus y1 over x2 minus x1. So my slope here would be y2, which is 14, minus y1, which is 7, over x2, which is 4, minus x1, which is 2. So 7 over 2 is our slope, or you could say 3.5. Either one would work for my slope. So I just used the formula that I was given. Say I just picked any two other points. So I'll do it as it was written before. Let's try m equals y1 minus y2 over x1 minus x2. Like I said to you, that since we're dealing with linear functions and the slope should be constant, all that matters is that we keep it in the same order, and we should come out with the same answer. So m equals 7 minus 14, ahead of myself. 7 is y1, 14 is y2, over 2, x1 minus 4, x2. So all I did is I picked my x1, y1s off of my coordinates. All I did was label an order, made coordinates, and just plug those into my formula. So now I get negative 7 over negative 2, which is the same as 3.5, or 7 over 2. So notice how I got the exact same thing. The only difference is I had to deal with negative numbers. And that's why I choose to use y2 minus y1 over x2 minus x1. A lot of times it'll avoid negative numbers. So there's a couple different cases in slope or rate of change. So looking at this line, I'm going to pick 2 points off the line and figure out my slope. So I use slope and rate of change interchangeably because they more or less mean the same thing. So I have this point, -2, -2, and this point, 3, negative 2. And I'm going to find my slope. So I chose this to be my x1, y1, and this to be my x2, y2. Wouldn't have mattered if I chose it the other way, but this is just using that same slope formula. So I could say that my minus minuses become pluses, and 0 over 5 is my slope. Well, 0 dividing anything is just 0, so my slope is 0. And for horizontal lines, my slope is 0. That's a special case that you need to know. M, or slope, is 0 for a horizontal line. And I proved it here by using my slope formula and picking 2 points off of my line. Came out with a slope of 0 for all horizontal lines. You can realize that because there's no change going up or down, the change is non-existent. It's just going straight across. And as we did in Unit 3, we talked about what does a straight line on the graph mean? Constant distance, constant height, constant speed, anything that is not changing. So what's the rate of change of this line? It's a vertical line. Let's pick a couple points off. So we've got point negative 4, 4, and negative 4, negative 1. So x1, y1, x2, y2. Negative 1 minus 4 over negative 4 minus negative 4. Negative 1 minus 4 is negative 5. Make this a plus, the two minuses next to each other. So that's negative 5 over 0. And for anyone who knows some of the properties of 0, you can't divide by 0. It's illegal. Therefore, our slope is undefined. And that goes for all vertical lines. So our slope is undefined for vertical lines. So as we found here, you're dividing by 0, which is illegal. So our slope is undefined because that's not a number. It's nothing we can even imagine. So slope is undefined for all vertical lines. One last little bit of this beginning part of the unit is slope-intercept form. Again, we dealt with this in Unit 3, y equals mx plus b, where the slope is m and the y-intercept is b. If you remember during that unit, we found our change in y over our change in x to get our m, and tested a point to get our b. There's still a video on Edmodo for that. So looking at this line, it's asking us to find the slope, y-intercept, and then write the equation. Well, the first thing that's easiest to find is the y-intercept, and that's where we cross the y-axis. So this is the y-intercept. That's where we cross the y-axis. If you find this point, it's your b. So b equals 3. Now our slope is our change in y over our change in x. So we can pick off 2 points. We could say point 0, 3 and negative 3, 2. So we'll call this x1, y1, x2, y2. So m equals 3 minus 2 over 0 minus negative 3. Make that a plus 1 over 3. So m is 1/3, and all we do is plug it right into the equation. Y equals 1/3, that's m, x plus 3. Okay? There's one other way you can do that on the graph. It's a little bit trickier, but if you get the hang of it, it can be very simple. So you find a corner of a box, say this one right here at 6, 5, and you find the next corner of the box. You figure out how you get there. The next corner happens to be at 9, 6. So if you go up 1 and right 3, you get to your next point. And that would be slope 1 over 3, because 1 is your delta y, and 3 is your delta x. So we'll talk a little bit more about that in class. For this one, identify the slope and y-intercept, and then graph. So the slope is negative 1/2, right? It's the m piece. And your y-intercept is 8. So we first can plot our y-intercept, because that's where we cross the y-axis, so we might as well just put our point there to start. Now if our slope is negative 1/2, that means we're either going down 1 and right 2, because that would be a negative 1 over 2, or we're going up 1 and left 2, which is 1 over negative 2. All that matters is that either the top or the bottom is negative. Okay? That can be a little bit confusing at times, but something that you should have seen before, so hopefully you all remember that the negative directions are down and left, positive directions are up and right. And since the slope's negative, one's positive. Because when we divide a negative and a positive, we get a negative. So we can go down 1, right 2, or up 1, left 2. It's basically just doing the opposite on both sides. And you create this line. I know this is a longer video, but we'll be done in a second. So looking at this line, we learned that the slope of a horizontal line is 0. What's the y-intercept of this line? Well, it's 1, 2, 3, 4, 5. So if m is 0, b is 5. This is one of the last little tricks that you'll see in this unit. We're looking at a horizontal line, we're trying to find an equation. So if we put this in slope-intercept form, we would say y equals 0x plus 5. Well, 0x doesn't make a lot of sense because that's just 0. So we can get rid of it and just say y equals 5. The moral of the story here is, for horizontal lines, the equation is y equals whatever b is. So wherever we cross the y-axis, that's our equation. So obviously, if the horizontal line is different, so is the vertical line. We know that this slope is undefined. We learned that earlier. So if the other one, if the horizontal line was y equals, the vertical line, which has an x-intercept, is going to be x equals. So it's going to be x equals the x-intercept. And this one's x-intercept is at 3. So the equation of this line would be x equals 3. And for all horizontal lines, it's going to be x equals, or all vertical lines, it's going to be x equals. So for all vertical lines, x is going to equal the x-intercept. And that's pretty much it. So you saw a lot here. You saw slope, you saw slope-intercept, and some special cases for horizontal and vertical lines.